September 7th, 2016. The name of today's presentation is Sun Energy Drain Part 7, September 7th, 2016. Let's begin. As of September 7th, the sun is still going dark at all wavelengths, from X-ray through ultraviolet to visible light. When I first saw that the sun was disappearing in the 450 nanometer, 4,500 angstrom wavelength, which is the only visible light wavelength that SDO detects, by the way, I thought that the image had simply been removed. It turns out that the sun is actually going dark in the visible wavelengths as well as the other wavelengths. The problem with the visible light images is that they are only updated once per hour on the half hour. So if the sun is dark or half dark at the time that the image is updated, this is what is shown for the next hour. Figure 1 then shows some interesting images of the sun and visible light detected and updated in this manner. Okay? Figure 1, image of the sun in 450 nanometer visible light wavelength detected by SDO on February 21st and March 12th at 2016 at 6:30 UTC, excuse me. Now, since only a portion of the sun is seen in these images in Figure 1, the sun is clearly going dark in visible light wavelengths. Figure 1 also shows that this darkening of the sun did not just happen in August, September of this year, it's also happened in February and March of this year. Every 6 months? In fact, it will be shown below that it has been happening since August of September of 2010. Wow. Figure 2. Images of the sun as detected by SDO in 19.3 nanometer ultraviolet between 6:31 and 7:47 UTC on March 1st, 2016. The last 3 images are at 6:45, 6:46, and 6:47 UTC Coordinated Universal Time. Table 1 shows the times during which the sun has been completely dark or partially dark during August and September. The table shows that we are now on the 18th day since the sun first went completely dark for a period of time on August 21st, 2016. It also shows that the time during which the sun was dark, or at least partially dark, increased until August 30th and then decreased. This is a sign that the drain on the sun's energy drain is decreasing for now. But it also has a sign that this is a cyclic event and has therefore happened before. I totally agree. A search revealed it indeed that has happened before. Table 1, time intervals during which the sun has turned dark in the 19.3 nanometer ultraviolet wavelength as detected by SDO, Satellite Solar Dynamics Observatory from August 20th to September 7th. The last column indicates whether the sun went dark in the visible light spectrum. Okay? From left to right, it reads day, number, day, August 20th to the 31st, and September 1st and 2nd, time that started disappearing from the 19.3 nanometer at UTC time. Completely gone in 19.3 nanometer at UTC time. Started reappearing in 19.3 nanometer at UTC time. Completely back in 19.3 nanometer at UTC time. Time it was gone in 19.3 nanometer for minutes, and time during which part of sun was dark in minutes. Okay, sun gone between 6:30 and 7:30 in the 450 nanometer, which is visible light spectrum. Okay. So, general layman's observations from my point of view, again, the time is getting earlier in the day. You can see that in both columns here. This has actually gotten earlier, but not as significant. This appears to have gotten earlier too, but not as significant as these two columns. The number of minutes is increased. The number of minutes is increased, but then it started going low. And here, yeah, okay, so it started, it like went up and then kind of came down, just kind of like a visual presentation. Yeah, okay, I see what you mean. All right, awesome, good job. All right. You're right here. And then decreased. Okay. Very cyclic and pattern. Very secular pattern. Table 2 shows what happened to the sun between February 18th and March 14th of 2016, and what happened was similar to that which was happening more recently since August 20th. The sun was gone at least partially for a period of time each day for 24 days. It is obvious that it stopped emitting ultraviolet and X-ray radiation for a period of time each day for 24 days. It also is clear that it stopped emitting visible light in the 450 nanometer wavelength, but it could not be determined exactly for how many days because of the hourly updating on the half-hour issue. If the sun goes dark and ultraviolet after 6:30 and before 7:30 UTC, the image that is shown for the 450 nanometer wavelength visible light spectrum between 6:30 and 7:30 UTC is the one taken at 6:30 when the sun had not yet gone dark. Since we now know when the darkening effect on the sun was repeated, we can calculate a period, time for a cycle to repeat itself, circular pattern, whatever, and go back in time and look if this has happened in previous years. Okay, the time between February 19th and August 21st is 184 days, or about 6 months. So this is the expected period, time it takes for a cycle to repeat itself for this event. In order to save time, I looked at one day that should have been somewhere in the middle of the sun going dark cycle as far back as 2010. The results are shown in Table 3. Figure 3 below shows the sun going dark on March 15, 2011, proving that the same thing was happening to the sun back then. Had to have been, right? If it's ever 6 months since 2010. Great data point. Table 2, time intervals during which the sun turned back, time intervals during which the sun turned dark, not back, in 19.3 nanometer ultraviolet wavelength as detected by the SDO satellite from February 18th to March 14th. The last column indicates whether the sun went dark in visible light. Reading from left to right. Day, the date, February 18th to 29th, and March 1st to 14th. Time started disappearing in the 19.3 nanometer. The time it was completely gone in the 19.3 nanometer. The time it started reappearing in the 19.3 nanometer, completely back. The time that it came back in the 19.3. Time that it was gone in the 19.3 nanometer. Time during which this part of the sun was darkened, the amount of minutes, and the time that the sun was gone between 6:30 and 7:30 in the 450 nanometer. Similar pattern, right? 7 o'clock, it gets earlier and starts to go back towards 7 o'clock. 7 o'clock, right? All the way up till 6:31, and then it starts going 6:44, implying it's going back to normal, whatever that is. 7:26 to 7:04. So it was earlier. So it got later and later and then started getting earlier. 7:37 up to 7:01. Okay, 6 minutes, right? Goes all the way to like 70, comes back to like 20. The same pattern, right? 27, 67, 73, 70, 60, 44, 14, right? So it's kind of... All right. Let's proceed. Great pictures, by the way. Thank you. Figure 3, images of the sun in the 19.3 nanometer ultraviolet between 6:36 and 7:35 UTC on March 15, 2011. Table 3. Time intervals during which the sun turned dark in the 19.3 nanometer ultraviolet as detected by SDO satellites in the years 2015 to 2010. The last column indicates whether the sun went dark in visible light. And reading from left to right, Table 3 is identical to Table 1 and 2, year, date, the time at which it started disappearing in the 19.3 nanometer, time as to which it was completely gone, the time at when it started reappearing, when it was completely back, how many minutes it was gone, time during which the part of the sun was darkened, okay, how many minutes, and the sun gone between 6:30 and 7:30 in the 450 nanometer, which is the visible wavelength light spectrum. Okay. Table 3 contains the initial results from searching back for the times when the sun went dark using the middle day and the 24th day dark sun event in February-March 2016, i.e. March 11th. So a search was done on March 11th and September 11th from 2015 to 2010 for signs of the sun going dark. By September 11th, of all days, 2011, it became obvious that the 11th of that month was getting too close to the beginning of that particular cycle. So a search was done on September 13th, okay, and then in 2010, the search was done even later on March 15th. September 2010 seems to be the first time that this event occurred, as the sun did not go dark at all on March 2010. The time during which the sun is gone in the 19.3 nanometer wavelength on March 11, 2012 could not be determined because the images were not updated after the sun initially lost a little of its surface emission. This is a trick often used to hide the fact that the sun is going dark on other satellite images, like, for example, SOHO. So what is happening to the sun is a cyclic event that's been happening since September of 2010. This suggests that this event is happening because the sun is in alignment with another body, probably a star, that does not emit in the visible spectrum. If that is the case, it is likely to be a brown dwarf. Figure 4 below shows the sun in the 19.3 nanometer ultraviolet light between March 15, 2010 and September 11, 2016, before or after going dark at the same 6-month intervals used in Table 3. Notice how much brighter the sun looks in the 450 nanometer visible light wavelength in March of 2010, before the darkening of the sun cycle began, than it did after, and especially than it does in 2016. It's obvious that the sun has lost a lot of its brightness. Therefore, the sun is losing its energy to the object it is aligning with, possibly a brown dwarf star. It is also possible that since this object is absorbing the sun's energy, that it has gained some brightness. If it is indeed a brown dwarf star, then it may start emitting its visible light wavelengths soon. This happens, it will start emitting in low energy visible light, i.e. red light. If that's the case, it will look red, but not nearly as bright as normal red stars. And since the brown dwarf stars are about the size of gas giant planets, it may look like a large red planet. Wow. Figure 4. Images of the sun detected by SDO in the 450 nanometer visible light wavelength from March 2010 to September of 2016. The dates are from top left, March 15, 2010, September 15, 2010, March 15, 2011, September 13, 2011, March 11, 2012, September 11, 2012, March 11, 2013, September 11, 2013, March 11, 2014, September 11, 2014, March 11, 2015, September 11, 2015, March 11, 2016, and September 7th, 2016. In conclusion, the idea of two stars not too far away from each other going through a 24-hour day of alignment every 6 months is strange, since stars are supposed to be able to emit and absorb energy from every point on their surfaces, which are spherical. However, it seems from the results shown so far that this particular star is only able to do that in one particular direction, possibly because there's too much dust gathered around it in every other direction. It means that the star has a 184-day rotational period, 6 months, and for 24 of every 184 days of its rotational cycle, the side that absorbs and emits energy faces the sun and absorbs its energy. The reason I comment on 6 months is due to a man named Dave Dobbs, his YouTube channel. I will put the links below, where he has claimed that there is a 6-month cycle. And he looks at flooding in Europe in particular. A physicist's thoughts. Have a great day. Thanks again. Bye now.